whenever you have sine of same argument, cos of same argument, multiply and divide it with 2 to the power of whatever number is there. In this problem, you have square. So you need to multiply and divide it with 2 square. So what will happen to the numerator? It will be 4 times dx divided by 2 times sin x cos x, the whole square. I hope you understood. This is 2 square with which I multiplied. So I combined it with sin x and cos x. So what will happen here? It will be 4 times integral of dx divided by, this is sin 2x, right? So sin 2x, the whole square. And this can be written as 4 times integral of 1 by sin square x is cosecant square. So cosecant square 2x times dx. What is the integral of cosecant square? It is minus cot. So answer will be 4 times minus cot 2x plus c. But if you observe, there is no option like that. So we have to manipulate it. So integration is done. So minus 4, if you take it out, this can be written as cos by sin. So what is cos 2x? It is cos square x minus sin square x divided by, denominator is sin 2x. We have only one formula for it, which is 2 sin x cos x. So 2 will cancel this 4 twice. So minus cot 2x divided by 2. So 2 will cancel this 4 2 times. So what you have is, you have a 2 here. So 2 and 2 will get cancelled. So cos square x minus sin square x by sin x into cos x. Right. So cos square x divided by sin x into cos x will be cos x by sin x, because one cos will get cancelled, minus this will become sin x by cos x plus c. So what will the answer be? It will be cot x minus tan x plus c. Is there a minus outside? Yeah. So minus is there, no? So there is a minus here. So this will become minus, this will become plus, right? So tan x minus cot x plus c, option should be D. Okay. So wait. The same question, integral of dx. So let me call it as alternate method. Integral of dx divided by sin square x into cos square x. Right. So whenever you have this 1 by cos square x, it can be written as secant square x. So this you can write it as secant square x dx divided by sin square x. But logic says, if the numerator is secant square x dx, I need to have a tan x in that problem. So for me to get tan x, what I'll do is I'll divide it with cos square x and compensate it with cos square x. Are you able to understand? Right. Now listen, integral of this secant square x, I am leaving it as it is. The secant square, I am leaving it as it is. I have one more 1 by cos square, which is going to be secant square. So don't write it as secant power 4. I'll tell you why. The whole divided by sin square x by cos square x is tan square x. Makes sense? Now what you will do is 1 secant square x, leave it as it is, because when I substitute tan x as t, I need that secant square x. So what you can do to the other secant square is write it as 1 plus tan square x. Makes sense? You'll write it as 1 plus tan square x. So this will be 1 plus tan square x times secant square x dx, the whole divided by tan square x. Right. Now what can you do? You put tan x as t, that implies secant square x dx will be dt. So integral of 1 plus t square by t square times dt. This will be integral of, what is integral of 1 by t square? Okay, I'll write another step. So integral of 1 by t square plus 1 times dt. So what is the integral of 1 by 1 plus t square? It is minus 1 by t. Plus what is the integral of 1? It is just t plus c. You got the answer c. Minus 1 divided by what is t? Tan x. So minus 1 by tan x is cot x. So minus cot x plus t is tan x plus c. I hope it's the same answer. Yes, it still works. So your method also will work, but you need to do a manipulation to it. Is that clear?